The most diverse substances are transported and distributed in piping systems every single day. They can include aggressive fluids in the chemical industry, hydrocarbons in petrochemistry, or steam for energy transmission. The fluids flowing through pipes often have completely different properties. Therefore, different principles are required for their measurement. One principle is flow measurement based on dynamic pressure detection using a pitot tube. Some 300 years ago, Swiss mathematician and physicist Daniel Bernoulli discovers a direct relationship between the pressure and speed of a fluid flowing in a pipe. At the same time, the French engineer Henri de Pitot is constructing a device for measuring the traveling speed of ships using flow pressure. His instrument is known as the pitot tube. Here is how this measurement method works. Pitot tubes have a rod-shaped measuring element that is inserted into the pipeline perpendicular to the flow direction. On the front and rear of this probe are several holes. Two separate tubes connect these holes to a differential pressure sensor. With its two pressure chambers, separated by a diaphragm, the tiniest pressure differences in the flowing fluid can be precisely measured. The individual pressure taps are distributed along the entire pipe cross-section to ensure a representative measurement. If there is strong interference in the flow profiles, it's advisable to fit a second pitot tube, rotated by 90 degrees. If the fluid is not flowing, the pressure before and after the probe is essentially the same. As soon as the fluid starts to flow, an additional impact pressure against the front of the probe is generated, also known as the dynamic pressure. On the rear of the probe, in contrast, only the static pressure, which is not related to the flow, is still measured. As a result, different values are detected in the pressure chambers of the sensor. Higher pressure against the flow and constant pressure on the rear of the pitot tube. This pressure difference is a direct measure for the flow velocity and thus the mass and volume flow in the pipe. The higher the flow velocity, and therefore the dynamic pressure, the greater the differential pressure measured. Pitot tubes are able to register the flow in both flow directions. This means that balancing measurements, for example in gas pipeline networks, can be carried out at any time. Continuous improvements have been made to pitot tubes over the past decades. Devices with a built-in temperature sensor, for example, together with a flow computer, can also calculate temperature-dependent mass and energy flows. This feature is particularly important in industrial processes involving saturated steam or gases. A unique feature is that pitot tubes can register flows in extremely large pipelines. This advantage applies not only to square ventilation ducts, but also to the measurement of flue gas or exhaust emissions in large chimneys of up to 12 meters in diameter. Pitot tubes from Endres & Hauser are being used increasingly in industry for cost-effective flow measurement. Easy installation, minimal pressure loss, and high contamination resistance are the key advantages of this measuring principle. For all applications, we have the right solution. Endres & Hauser, your single source supplier for measurement technology.